All right, in this section, we're going to be talking about zero and negative exponents. And it comes from something that we already know how to do. So if we look at this first expression, it's x to the fifth over x cubed. So we had a quotient and we have repeated factors. So we always use canceling to do this. So if we think about it, we can set this equal to, and when we cancel, we just use the powers, right? So x to the fifth over x cubed, we can cancel all the three x's in the denominator with three of these leaving two. So we know the answer to this has got to be x squared. So if you think about what we do basically subtract. So for the sake of argument, we could subtract exponents. We could basically say this is the same as x to the fifth, and then the denominator, we could take that and subtract that power to get x squared. No, I don't like subtracting exponents. I think we want to look at expressions and quotients and always cancel. We will always think to cancel. So this is just for argument's sake. A lot of textbooks and so on will explain it this way. So if you look at this down here, it says, for argument's sake, we could subtract exponents. And actually, this is what we would see in our textbook of how to approach factors in a fraction or fractional factors. Um, So it's called the quotient rule. We called it the same thing, but we think of it as canceling and then keeping track of factors that are left. So if we take this to a new level, to a different level, and look at the next expression, we notice if we did canceling again, so if we thought about canceling, um, we would get, well, now x cubed cancels all the threes, all the x's in the numerator cancel with 2, and we would be left with 1 over x squared. So the two x's would be left in the denominator when we cancel. So by, like I say, by canceling, we're able to just write our answer 1 over x squared. Well, if we think of subtraction, then if we go with the textbook, the answer would be x to the 3 minus 5. And 3 minus 5 is x to the negative 2 power. So 3 and negative 5 is negative 2. So these negative powers actually act, and they have to be the same. X to the negative 2 is the exact same thing as 1 over x squared. So if you stick with the subtraction idea, then we need to make this definition. So for negative powers, if we have x, a factor of x, and it's raised to a negative, like a negative n power, then that's the exact same thing as 1 over the factor of x to the nth power. So it basically just moves the factor into the denominator. So we know when we have a factor in the denominator that it basically represents a fractional factor. So that's what I like to call factors in the denominator, fractional factors. All right, so let's just practice with this. If we see expressions with negative exponents in these examples, then we want to apply that negative exponent, basically write it as a fractional factor. So for this first problem, the factor is 3, and it's raised to the negative 2 power. So the negative power, so we have this negative power here. All that's telling us to do is rewrite this factor in the denominator. So it would be 3 to the second power. And 1 over 3 to the second, so we just convert that whole factor to the denominator, and then we could make this 1 over 9. We could apply then. So if we look at the next problem, again, we just want to make sure that we're seeing the factors. So we always want to identify factors first. So we're just going to put parentheses around the individual factors. So this term is -2, then we have times. So this has a factor of -2. X to the -3 would be the next factor. So those are the two factors. So the only factor that has a negative exponent is the x. So that factor of x is going to get moved to the denominator. So this would be equal to the factor of -2 stays in the numerator, but then x to the -3 goes to the denominator as x cubed. It just represents that fractional factor. Okay, so now we have an idea of what negative exponents do. So let's take it further. What if we have something like x cubed over x cubed? Well, again, by canceling, this is just a fractional factor of 1. So we know by canceling that the answer to this has to be equal to 1. It's just a fractional factor of 1. But if you apply the subtraction idea and say, well, can I take the exponents and subtract? That'd be x cubed, or x to the third, minus 3, which is the denominator. And if I do this subtraction, I would get x to the 0 power. And yeah, the x to the 0 power, we have to basically defines a fractional factor of 1. So this is the same exact thing as a fractional factor of 1. So our definition means basically anything, any factor to the 0 power is always equal to 1, and it represents a fractional factor of 1. So again, we want to keep track of that. If we use subtraction to think about canceling, we would have to worry about x to the 0. When we cancel, never ended up with x to the 0. We just left it as a factor of 1. So now we want to try some examples where if we run into factors with 0 as a power, how do we handle it? Okay, again, when we do these, we want to look for the factors first. So we want to identify all the factors. So in this case, we have a factor of 3. We have a factor of x to the 0. And then we have a factor of y to the -2. So we're just going to evaluate our factors. X to the 0 would be the same as a factor of 1. Y to the -2 is the same as 1 over y squared. So finally, we can write our answer. 3 times 1 is 3, so that would be a 3 in the numerator. And then the y squared ends up in the denominator. Here, the next example, we notice we have a negative outside, and this represents a factor of -1. So the -1 factor is by itself, and then I have x to the -4th, and then I have a y to the 0. So when I rewrite this, if I evaluate the factors, I have this -1. X to the -4 is the same as 1 over x to the 4th, and y to the 0 is the same as 1. So our answer then is just going to be a -1 over x to the 4th. But this is the one we have to make sure we watch. This negative on the outside of a variable represents a factor of -1.